Hello everyone. Today is 7th January, MSc second year 3rd class.
The first session was organic chemistry, synthetic organic chemistry, orange color book. We started with Grignard reagent, reactions of Grignard reagent. It is an organometallic reagent which functions as a nucleophilic reagent. There are different types of different types. One is organolithium compound. The other one is organocopper reagent and the organomagnesium compound, which is very commonly used, frequently used. It is on page number 105. All the aldehydes and ketones undergo reaction with RMGX to produce. They produce for 1 degree, 2 degree and 3 degree alcohols. Aldehydes and ketones both give tertiary and secondary alcohols. Next, reaction of RMGX along with esters and acid halides. It is on page number 107. This is the reaction. Simple esters reacting with the Grignard reagent, the product depends on number of moles of reagent used. If 1 mole is used, ketone will be produced. Here, when 1 mole of Grignard reagent is used, ketone is produced. When the next mole of reagent is used, alcohol is produced. That is tertiary. Now this is the reaction and this is the way it proceeds, mechanism. This is the mechanism. Next is reaction with carbon dioxide. The product that will be formed is carboxylic acid. You can see here RMGX with the CO2. We get this product which on hydrolysis produces carboxylic acid. It is a very important reaction. Next is with alpha beta unsaturated carbonyl compounds. There will be two product formed. 1,2 addition can happen and 1,4 addition can happen. Saturated carbonyl compound is produced here. Organolithium complex, that is RLI. Here halogen and metal exchange takes place. Lithium goes to methyl and RX will be formed. Applications, these are the applications: reaction with carbonyl compounds, primary, secondary, tertiary alcohols are produced. Reaction with carboxylic acids. This one, this is the mechanism. Grignard reagent and their stability. With RLI is very highly reactive than RMGX, which is more reactive than R2CU. Reaction with an alpha beta unsaturated carbonyl compounds. Now, organolithium compounds, when reacted with alpha beta unsaturated carbonyl compounds, undergo only 1,2 addition. When it is magnesium, it undergoes 1,2 and 1,4. Here only 1,2 addition is shown. Elimination groups are on same side. Here formation of syn elimination, it is on page number 117. The whole reaction mechanism, everything is given here. In this, this reaction is called as cope elimination if oxygen is present, and it is called as Chugave reaction if sulfur is present. Here, if sulfur is present. Now, this elimination, the groups are on same side due to steric crowding. Now, this reaction is also called as pyrolytic elimination reaction. So, phosphitane is produced. Next is page number 120. Preparation of alkenes from sulfones. Now, here sulfones must have at least one alpha hydrogen. That is the reaction of alpha halosulfones with base as final and episulfone, which forms as alkene as final product by the extrusion of sulfur dioxide. It is on page number 124. Now base abstract the proton. This is the sulfone. Here alpha 1, at least one alpha hydrogen is present. The Catalyst used here is tertiary butoxide potassium along with sodium amalgam and ethyl alcohol. This is the reaction mechanism. Now alkenes from 1 to syn-diols. This is a Corey-Winter reaction. Cis 1,2-diol. When they are used, cis alkenes are produced. Now this is the reaction mechanism in which 2 moles of HCl, they will make alkene molecule like this. Next is alkenes from aryl sulfonyl hydrazone. It is on page number 130. The name of the reaction is Shapiro reaction. You can see it here, Shapiro reaction. This is the way it goes. Here, excess of alkyl lithium is used. Here, excess of Grignard reagent is used. Shapiro reaction, excess of reagent is used. This is the mechanism in which vinyl lithium is produced. Lastly, reduction dimerization of carbonyl compounds. Reductive dimerization. Lastly, reductive dimerization of carbonyl compounds. It is on page number 132. It is ketones, removal of 2 moles of oxygen. Now to get that, we use titanium 0 state. To make this titanium 0 state, this is the reaction that has to be followed. 2 moles of ketones, 2 ketones, in which 2 moles of oxygen are removed. Here 2 oxygen are removed and we get an alkene. Lastly, it is reductive dimerization of carbonyl compounds. You will get it on page number 132. Here we use titanium in oxidation state 0 and this is the reaction. Removal of 2 moles of oxygen takes place and an alkene is produced. Now to make this titanium 0, titanium is in 3 state. To make it in 0 state, we do this kind of reaction and we get titanium 0 state. So this will take place, the titanium, because of the presence of titanium, the oxygen molecules will be removed from here in this way and we get an alkane along with 2 titanium oxide. We had a break. I meet you after the break.
This radical ion reacting here when donate the electron, then convert into titanium plus. Titanium plus 1 charge. Okay, this is a titanium plus 1 charge metal. So these carbonates, this radical ion carbonate, the negative charge of oxygen attack into titanium surface. This is a titanium, and this is a titanium. Titanium, not involving titanium plus 1. This is a titanium. Okay, this is a titanium. When it is the negative charge of oxygen attack it here. Okay, like this. Lower parameter are to titanium and lower parameter are to titanium and radical triangle. Okay, by radical function. Now it is like this. Okay. Now it is involves bond formation between these two radicals takes place. Bond formation between these two radicals takes place. Then the product is next one is homoelectric cleavage of these bonds. Homoelectric cleavage of these bonds. And then what's happened here? Homoelectric cleavage, here radical, here radical. Okay? Bond formation between these two radicals. Double bond. Okay? Plus titanium oxide. Titanium oxide is the product. Titanium oxide is the product. This is the formation. There's 2 moles of titanium oxide is the formation and carbonyl compounds in the product. is the reductive coupling of reductive derivative of oxidative derivative of carbon. Simply just remove oxygen and join the bonds.
I'm heading back to my class after the break. It's so green, you can see. These are the corridors of my college, and there's this room in which the lecturers can have a nap during the break. Just joking. And these are the steps which go to floor 4th. This is my classroom. It's a spectrometry lab where all we are sitting for today's class. And you can see here boys are still not come back. There's this window. When you get bored, you can look out of the class.
So we are back to the class after the break. After the break, at 2 o'clock, we had drugs and pharmaceuticals, green color book. In this, the topic was combinatorial synthesis. Here it is on page number 87, you can see. In this, what are the different methods of production of large number of compounds in short period was taught. This is the, like for example, 1000 molecules. Let us say 1000 molecules. Random screening was done and 10 molecules that may only satisfy our requirements. So at such times, after the break, so we are here after the break. Drugs and pharmaceuticals was the second session. It is a green color book. In here, combinatorial synthesis was taught, in which, for example, production of large number of compounds has to be done within a short period of time. So different methods are there for that, and for that also there are different requirements. These are all the requirements. The example of solid support is Merrifield and Tentacle. Now here when a linker is used, it will contain active functional groups. You can see this methylene group. Methylene, it is attached to two functional groups. These both are active, and when both are active, we have to protect one and let go of the other. When we have to protect one functional group, we protect it using sodium hydroxide. Here we have done protection using sodium hydroxide. We have protected the amine group, and this way carboxylic acid group can be protected. If 20% of sodium hydroxide along with this phenyl carbonyl chloride is used, then we protect carboxylic acid group. Next, Merrifield resin is a cross linkage of divinyl benzene. So this is the way, like for example, we are having this ring. This is continuously, means many rings like this together will form such an internal strain. Now this is there here inside. CH2Cl will be outside, and this whole thing is there inside the sieves strain. This structure will form the resin support. This now, here what are the differences of a solid phase and solution phase? Solid phase also can be used and a solution phase can be used. These are all the differences. Next, types of combinatorial synthesis. One is parallel synthesis and the other one is mixed synthesis. Parallel synthesis, same products, and mixed synthesis, different products, and mixture of products, both can be formed. Now for this, we have examples of Houghton tea bag procedure and Well and Array's pin and stick method. Okay, these are the notes that were given. Well and pin array is an automated method. Multiple wells are there. Like wells are there, multiple wells will be there. In that is the pins with the solid support will be kept. these are the pins, and these are the solid supports. Now solid supports will be coated with resins like this. These resins are made up of these kind of structures. Then next one is mix and split method, or it is also called as Fuka method. This kind of these are the different steps in which they are made. And finally, if you want, you can add after wash to continue compounds. That's it for today. Next class will be on 21 January. See you back again with another fresh content. Be ready for it. Thank you.